Hey guys, so let's start today's POTD of Leetcode. So the question says smallest subtree with all the deepest nodes. We are given a root of a binary tree. The depth of each node is the shortest distance to the root. Return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has all the largest depth possible among any node in entire tree. Subtree of node is a tree consisting of that node plus set of all descendants of that node. Okay, I think I got the question. Let's do it in the whiteboard. So you can see this is the root of the tree. Okay, and what is the depth of this particular level? This is at a depth of 1. This whole level is at depth of 2. So by level, I am meaning this. As you can see, 6 is at a distance of 2. Same for the 2, same 2 distance for this 0, and 2 distance for this 8. Okay. So this particular two nodes, 7 and 4, has the depth of 3. So basically, we need to find the deepest nodes. Then we need to give out the root for which all the deepest nodes lie inside its subtree, like this. We need to output 2 here. You can see here the answer is 2. 7, 4 are the childs. So we basically need to return 2. You can see here, return the smallest subtree. Okay, cool. Let's take a generic example of this. Okay, suppose we have a tree like this. Okay, so now you can see clearly the answer is basically this particular 3 nodes. These are at depth of 3, and the root node which consists these two is basically the LCM of these two nodes, which is basically this node. But we need to return the nodes such that all the deepest nodes lie below it. So we need to cover this also. So what is the LCM of this with this node? It's basically this node, right? So basically the problem trims down to find LCM of all deepest nodes, right? And finding LCM is easy. If we are at a particular node, then we will just check if we have the nodes below it. Now in this problem, as we are more concerning with depth, so we will be giving out the root that has the deepest depth childs. What I mean about it is, let's have a dry run. So we are doing a DFS. So when we are at this node, we will check if we have a left node or we have a right node. We don't have anything, so we will simply return depth 0. And what is the probable answer? Is basically null. Similarly, 0 and null. So at this node, we have two options. The left one says this, right one says this. So as both of them length is same, so we can pick up anyone. Okay. So we just pick up the depth 0 plus 1 because we are also taking this node, and then as we found answer in both the sides were equal, then we will return this particular node root. So for simplicity, if you can mark this as 1, 2, 3, 4, 5, 6, 7, 8, 10. So if we can see that we'll be returning here 5. Okay, let's just erase this. Okay, let me just perfect. So now for this node 3, we have left of 1 from here with root as this. Now this doesn't have any root. If doesn't have any root, so we will be returning 0 depth with null as the root. Okay. Now 3 node has an option of 1 comma 5 from the left, from the right it gets 0 comma null. So it sees that it has a better length, right? 1. So what we will be returning is 1 plus 1. It will be returning 2 along with the longest root. So the left one is longest, so we'll be returning 5. Okay. Similarly, we'll be at this 4, we'll be returning 1 with 4 node. It is just same as just 5 node, right? If node, so it has 0 length from this side, 0 length from this side. So along with this particular node, it returns 1, and since both of them are same, then we will return 4. If we get any side, the left or the right length greater, suppose the left side is greater, then we are sure that all the deepest nodes are in the left side, right? Now as we see that both of the sides has same depth of nodes, we will be returning root because that might be a possible answer. You never know. Now this 2 sees that it has option of 2 length and 1 length. Since this length is greater, so it is sure that this particular side of the tree has the deepest nodes. So we can simply just ignore this particular side, right? So we will be returning 3 size along with 5 as a node. And if you can see clearly by this distance, if you can see clearly, this 3 is the node that is having the deepest node, that is 5, and it is at the depth of 3 from the root 1, 2, and similarly we go down here, we'll be returning 1 with 9, we'll be returning 2. Okay, so it has 0 null, it has 0 null, will be returning 1 9. Okay, now it has 0 null, but it has a better this thing depth, so we'll be returning 1 plus 1, that is 2, along with its root. Okay, similarly this thing will return 1 with 10, this will return 2 with 10. Now at this point Look at look at this carefully. At this 6, we saw that both of them has equal depth. So that means both of the sides are equally contender. So we might be having the deepest nodes here. So we will be sending, we will be including this 6, that is length plus 1, that is 3, along with, as we have both the side as longest, so we'll pass 6 because that might be a possible contender, right? Now we move up, then we can see that same case. 3 is the length of from the left, 3 is the length from the right. We'll be sending 4 along with the root 1 because both the length are same. So what will we can achieve from this? So simple, right? If left side is greater than right, the depth, we'll be simply passing the depth plus 1 all the cases along with the left node, because we are ignoring this right. In the else case, if the right is greater, right, then we'll be again sending depth plus 1 along with right. So in this case, we can ignore left because it is lesser depth, right? Then in the final case, if left is equal to right, that means for this particular node, both the sides has equal depth. This might be a possible contender of answer. So we will be returning depth plus 1 along with this particular node. By root, I means this particular node. Okay. For simplicity, you can term this as node. Let's so as this is going to every node, so big of n would be the time complexity, and we also have auxiliary space complexity of this. It's n is basically the number of edges because we are traversing each as edge twice, one while going down, while going up. It's basically time complexity of DFS call. Let's just code it out. So we'll be having a helper function. Let's just have it. So the private class would be, so we can return a pair, one with the depth, one with the node, right? So it can be said that GFS. So we'll be passing the node. If that particular node is null, then we should simply return 0 depth along with null, right? After that, we will be calculating this pair of int comma free node for left. So how we'll get the left? We'll basically call for the left, right? Similarly, we'll be getting for right. And now the comparison phase begins. If the left dot first, that is having the left size, is somehow greater, then we will ignore the right side, right? So we'll be having the left dot first is the length plus 1, and we'll be sending the same root as left. Similarly, it is the other one case will be sending the right, and if this case alters, right? And if we are encountering the other case that left and right height is same, then we'll be just sending the, we can take left dot first, right dot first, because both are same, right? And along with this we can return the note. It will be a pair. Finally, you can simply return the DFS calls second item is the root. That's it. Yeah. So this particular code is passing. So let's try submitting this. So this is passing. So yeah, this is the solution for this one. Thanks.